So our final question on our sheet about colors in the sky are question number 6. And we're asking, where does the green flash come from? So what the heck is the green flash and why does it happen? Maybe you've seen it before. The green flash happens sometimes at just the very last moments of sunset, as the sun is getting lower and lower and lower in the sky, something like this, and maybe even a little bit later, something like that. Just as it gets to a portion like this, when just the last bit of it is about to disappear below the horizon, there's a green flash right there in the middle of the sunset. Here's a couple pictures of it. So this is sort of what we'd be talking about here. The sun getting lower and lower and lower in the sky. And just at the moment where it's about to set, you see this wonderful green flash. It's not unusual. It's not rare. I've seen it many, many times myself. I've never had a chance to take a photo or a video of it because the times I have seen it, I just wasn't quite ready. There was one time I saw a very prominent green flash that was very clear, but video camera, nowhere to be found. So it's something kind of fun to do if you're ever out watching sunsets, hang around until it's done and just stare at the sun, being very mindful of your eyes, and see if you can see the green flash. But let me just tell you where it comes from. So the green flash is definitely similar to rainbows in that it is a dispersion. It is a dispersion effect, okay? So let me let you watch this video now of the green flash, and then I'll come talk about it. So take a look. Okay, so I hope you enjoyed that. Again, that wasn't taken by me. I've never been able to sort of capture the green flash either by video or camera because I'm just never quite ready, but it's something that's fun to watch. And the green flash works like this. Let's get ourselves set up for... The green flash, maybe something like, let's do something like this. Here's the good old Earth right here. And maybe here's us standing way over here because the sun is setting. And the reason I'm drawing that is because we're barely above our own horizon now. And so let's just say that the sun would maybe be over here. We're really rotating away from the sun, maybe in this direction, getting away from it. Okay, and of course, what the sun is always doing is spewing its light out. All these other things sort of add. So here's maybe a light ray that's coming up like this. And I want to get white in there because we need it's a dispersion effect. So we need to get our color separation ready here. Let me move the sun down just a tad bit more, maybe something like that. So again, it's really at the extreme moments of setting where it's just at or below our horizon. So here's some white light coming from the sun here. And it's going to sort of go in this direction. And largely speaking, maybe the light ray would just keep going like that and entirely miss us. Like it just won't get to us at all because the geometry isn't right? The sun is setting, so the majority of the light rays are now hitting the other side of the Earth, which are getting their morning time. And it's hard to even figure how you're going to get a light ray that's going to even go into our eye. I mean, maybe this very extreme top one, if we're lucky, will sort of make it into our eye. But, my artwork isn't great, but maybe it'll just graze the horizon. But again, we're looking at the very extreme last moments of sunset, but I do want to focus on this ray here. Okay, so what happens, of course, is the ray does not keep traveling forward like that because, as we know, our Earth is surrounded by our atmosphere. So let's just get that drawn in there. So there's this atmosphere drawn all around the Earth, our nitrogen and oxygen, but we don't need to focus on nitrogen and oxygen in this discussion here, but there it is. And so what will happen, of course, is you may hopefully start to recognize now is sort of right about this location right here. There's a space-air boundary, right? And by space, I mean outer space where the light rays have been traveling across the solar system on the way in our direction. And of course, the air is the air in our atmosphere. So of course, whenever you get an airspace boundary like that, you'll get two things happening. You'll get reflection, you'll get refraction, and if you get refraction, you will get dispersion. Okay, so here we go. let's take a look at this interface right here. And I'll try to get my artwork to come out right. So what will happen here is, supposing then that here's sort of that airspace boundary right around in here. You can draw normal in there if you want to sort of think about your angles. It's up to you. I don't even know where the normal would be. I don't know, maybe something like that. And so as I said, we're definitely not going to get this light ray continuing off in this direction here, because it's going to refract at this surface right here. It'll reflect as well, but refraction is what we'll focus on. And so, of course, what will happen is the blues always bend more than the other colors do. So right at this point, the blues will bend like this. But we're not too concerned with the blues, because as we know now, this blue here has a big job in front of it, doesn't it? It has to travel all through all this thick air here, which is our atmosphere. And, of course, it's just going to get scattered out of the way. So by the time the blue makes it to our eye, after going through all that air, it's just going to be just this little pathetic bit of air of blue, because, like I said, as you know, the blue light all gets scattered out of the beam as it travels through air. And there's a lot of air here. That, of course, is what defines sunset. So we know, of course, that if any white light rays were making it into our eye, then they look very red. So there's a lot of red associated around the green flash, as you saw in the video. But now what about the green? Well, what about the reds, the red lights components next? Well, they don't bend as much as the blue does, so the red might sort of make it up and go this way, okay? So the reds aren't quite going to make it into our eye either. They're going to go up this way. What about the greens? Well, it is called the green flash, and the green is going to definitely refract at a larger angle than the reds and the yellows will. It's pretty similar to the blue. So in fact, the green is going to come in like this and do this sort of thing. It does have the chance of making it into our eye. So again, we see sort of a nice wrap of effects here. The blue light gets scattered going through the air, and we're not going to see it. The red over here is sort of at the wrong angle, but the green seems ideal like that. So, and that's where the green flash comes from. So if you ever happen to see the green flash, the reason for the flash there is dispersion at the space-air boundary. And it just works out. And, you can first say, well, why wouldn't it be the blue flash? Well, the blue doesn't make it to our eye because the blue would or should, but it has to travel through this atmosphere. And as we know, blue light doesn't travel well through the atmosphere. It gets scattered out in all different directions. So the green survives and gives us the green flash. So a nice example of dispersion there in nature once again. Try to look for it next time you're at a sunset.